Hi students, let us learn about magnetic field due to a current in a solenoid. What is a solenoid? Solenoid is nothing but the conducting wire wound in the form of a cylindrical coil. This looks like a helical spring. We know when electric current passes through a conducting wire, a magnetic field is produced around it. When electric current passes through this coil, the strength of the magnetic field will be more. The strength of this magnetic field depends upon the amount of current which passes through this coil. When current is more, the strength will be more, and also it depends on the number of turns. If there are more turns, the strength will be more. We understood that the strength of the magnetic field will be more in the case of a solenoid than a straight conductor. A solenoid is a coil of insulated wire having many circular turns wrapped in the shape of a cylinder. Let us now look into the pattern of magnetic field of a solenoid. This is a solenoid, and this solenoid is connected to a battery and a key. When the key is closed, the electric current starts flowing from the positive terminal of the battery to the negative terminal of the battery. The electric current starts flowing through the coil and comes back to the negative terminal. When electric current passes through this coil, a magnetic field is produced, and the magnetic field lines are shown in the diagram. The magnetic field lines are from the North Pole to the South Pole, and inside the solenoid, the magnetic field lines are from the South Pole to the North Pole. We learned in part 1 the magnetic field lines of a bar magnet. In this bar magnet, the magnetic field lines are from the north to the south pole, whereas inside the bar magnet, it is from the south pole to the north pole. The magnetic field lines of this solenoid is similar to that of a bar magnet. How do we know the polarity of this solenoid, whether this is north or south? If you know the polarity, say this is north and this is south, then it is easy for us to draw the magnetic field lines. You can draw from the north pole to the south pole, and inside from the south pole to the north pole. How do we know the polarity of this solenoid? Say the positive terminal of the battery is connected at this end and negative terminal of the battery is connected at this end of the coil. When you look at this face of the solenoid, the electric current is flowing in the clockwise direction. If the electric current is flowing in the clockwise direction, that end will be the south pole and the other end will be the north pole. If you reverse the battery connection, say this end is negative and this side is positive. In that case, you should look from this side. The electric current enters the coil in this direction. That is the clockwise direction, and hence this end will be the south pole and this will be the north pole. Once you know the north pole and south pole of a solenoid, it is easy to draw the magnetic field lines. You should draw from the north pole to the south pole, similar to the bar magnet. Polarity of the solenoid can be determined by using the compass needle or right hand thumb rule. We learned the right hand thumb rule in our previous slides. Remember, The anti-clockwise will give you the north pole and the clockwise will give you the south pole. You look at this diagram. This is the clockwise direction that will give you the south pole, and this is anti-clockwise direction and this will give you the north pole. When you write S, put arrow mark at the end of the S, and when you write N, you put arrow mark at the ends, and you can look into the direction. This is in this direction, which is clockwise. This arrow mark is pointing in this direction, which is the anti-clockwise. Anti-clockwise is the north pole and clockwise is the south pole. The end where the current is anti-clockwise is a north pole and where the current is a clockwise is a south pole. Please note the lines inside the field lines inside the solenoid are always parallel. These are the field lines inside the solenoid and they are parallel. This indicates that the magnetic field lines produced inside the solenoid at any point is of the same magnitude. That means that the field is uniform. The field is uniform inside the solenoid. What is an electromagnet? We understood that a strong magnetic field is produced inside a solenoid. If you introduce a magnetic material into this solenoid, that magnetic material will become a magnet. Say magnetic material, soft iron, is introduced into the solenoid. This soft iron will become a magnet when electric current starts flowing through the coil. This is called electromagnet because only when electricity is passed through the coil, this will become a magnet. A solenoid which has an iron core is called an electromagnet. The factors on which one magnetic field strength produced by the current carrying solenoid depends are the magnitude of the current, number of turns and nature of the core of the material. In this session, we learn about the solenoid. Solenoid is a coil of insulated wire having many circular turns wrapped in the shape of a cylinder. And the magnetic field pattern is similar to that of a bar magnet. And field is uniform inside the solenoid. To find out the polarity, always remember anti-clockwise will give you the north pole and clockwise will give you the south pole. You can remember in this way, south, you will write S, put an arrow mark at the end. Therefore, the south will give you the clockwise. For north, you write N, put an arrow mark at the ends. Then it is the counter clockwise direction. Anti-clockwise gives you the north pole and the clockwise will give you the south pole. The solenoid which has an iron core is called an electromagnet, which is a temporary magnet. You know bar magnet is a permanent magnet, whereas electromagnet are temporary magnets. Only when electric current is passed through the coil, it will become a magnet. And the factors on which the magnetic field strength depends are the magnitude of the current, number of turns and nature of the core of the material. Hope you understood this session. See you.